I'm Max Guernsey from Prodicore. In a previous video, I refactored this class here, this Flash Sale Manager, from being coupled to the system clock to being decoupled from it by way of this interface, the timeline interface. The purpose of doing that was to make it so that the Flash Sale Manager could be tested. Well, the question arose, how does one actually go about testing it? Specifically, how would I take this interface and use it to mock out the timeline for the purpose of testing? Well, the answer is that I'm going to make it so that there is a virtual timeline that works kind of like time, but in a way that I can control and that fast forwards at my leisure. So let's start with the test. I have a little scenario here for the flash sale. I say that it opens within 1 second of the start time. So if I have a flash sale S that's scheduled and its start time is a particular point in time, when it is 1 second before that time, then it is not open. However, when it is 1 second after that time, then it is open. And if I go ahead and run the test, we'll see that right now it fails, and then I'll show you why. So the issue here is that I've created all the bindings, and a lot of them work the way you would expect them to work. Scheduling it calls the Flash Sale Manager scheduler. Writing down the time is literally just recording the start time in some variable, and checking if the sale is or is not open is just asserting is open to be true or false, because that's all we've got to work with right now. The trick is that I don't have a good way of setting the date time. I don't have a good way of deciding now it's the right time. Now this much time has passed. And the reason is because right now, when we create a sale and schedule it, we schedule it with the actual timeline. It's coupled to the time that you and I experience, essentially. So the first thing I'm going to do is I'm going to extract a field. And I'll initialize that field in the initializer. We'll call it timeline. And there we go. This will give us something that we can then interact with in other places. Now, the next thing I want to do is replace this actual timeline with a class that implements the timeline type. Now, if we go and we look at the timeline interface, it really just has one thing, schedule action. We say when it's going to happen and what's going to happen. I want to create something that, like I said, works kind of like time. It goes forward and whatnot, but that I control and that fulfills this interface. So I'm going to create that here. I'll call it the virtual timeline, and I'll make it an implementation of timeline. And what do I do here? Well, I'm going to need to write down this information, so I'll make a list. Same parameters. I could probably just copy and paste them, but I don't usually do that. Let's say events. Okay, so now I can make it so that schedule action just records this information. So now whatever system uses this virtual timeline uses it, it calls schedule action, we're just going to put this in a list of events. So now I need a way for my test to control it. Well, we're going to need some things in order to make that happen. One thing we're going to need is a date time. We'll call it current time, and we will initialize it to the min value. And then I'm going to make a method called advance2. And one of the things this is going to do is it's going to set the current time to new time. The other thing it's going to do is loop through all the relevant events. I'll go make them relevant in a second, and invoke them. So now I just need to make sure that the events that I'm looping through are the ones that are actually relevant. So what I want when I advance to a new point in time, and I'm trusting the test to always move forward and stuff like that, because this is a test class. I don't need to, throw exceptions if someone tries to go backward or whatever, at least not yet. So what I need to do is find all of the events after the current time and before or on the new time. So I will say where event such that event.when is after the current time and event.when is less than or equal to the new time. And this is going to go through and run every single event that basically that hasn't already been run or isn't in the past, and then also isn't in the future of the new time. Now that I have that, I can switch my timeline over to be a virtual timeline. And then I can update the virtual timeline to simply advance to the new time. And when I do that and I run, this allows the behavior to pass, because one case it goes up to 1 second before the threshold, which will not invoke all of the scheduled events, on the threshold or later, and the other goes a second past, which should invoke the scheduled event. All right. Well, once again, I am Max Guernsey with Protocor. I hope you enjoyed this video. Be sure to check out our other videos if you think they might help. Thank you.